What's up, everybody? This is Coach Sharp. Welcome back to my Algebra 2 slash Advanced Algebra notes videos. Today, we are looking at a new topic to Advanced Algebra this year, 2023-2024 school year, which are matrices. They used to be in pre-calculus, but they've moved down. So there's not really a great way to describe matrices other than just kind of seeing them in action. So um, without much further ado, let's jump in. Where's my share screen? All right. So a a matrice or a matrix. Matrices is the plural of matrix. A matrix in mathematics is not a movie. It is not Keanu Reeves dressed in all black trying to dodge bullets or picking from a red pill or a blue pill or anything like that. What a matrix is, head over here, is a square or rectangular array of numbers, which means a display or a spread of numbers, which can be standalone or used to represent real world data. So you could just have some numbers displayed in a matrix. They can be by themselves. We could do some operations with them and equations, which we'll see in a second. Or they could actually represent some real world data. They kind of similar to like a frequency table. When we did statistics at the beginning of the year, in terms of getting real world data off of it. We're not really going to look at it in the notes because of the questions I eventually gave y'all on the homework that have to do with the real world data. It's not as much dealing with like within the notes we're talking about, but it's pulling data out of the matrices and kind of more common sense than anything, if you will. Okay. So we describe a matrix. I don't remember how. Yeah, I'll just do that. I might keep flipping that back and forth. I haven't really done many of these this year. Pretty much all my videos have been recorded. I did some more at the beginning. But anyway, um, we describe a matrix by its rows and columns, what we call the dimensions. Okay. So 2 by 2, top left in blue, 3 by 3, bottom right in black, 2 by 2, 3 by 3, kind of hard to mess that up. In the purple, we have 3 rows going across, 2 columns going down. So that's a 3 by 2 matrix. In the red, 2 rows going across, 3 columns going down. So it's a 2 by 3. You might see a 1 by 3 or a 3 by 1. You're not really going to see a 1 by 1, a 1 by 2 or a 2 by 1. I mean, I don't think off the top of my head. Maybe I'm mistaken. We're really not getting any bigger than that. I don't know if we're dealing with any fours or not, but definitely nothing bigger than a 4. If there's potentially like a 3 by 4 or a 4 by 3. I don't think there's any 4 by 4s. Definitely nothing bigger than that. The individual numbers are called elements, like in the periodic table, but they're just numbers. So if you say, add the correct elements together, that's all that means. We're not saying, add the proper elements together to make water, 2 hydrogen atoms and an oxygen atom. So that's not what we're talking about. All right. So, nothing really to do other than that. Just jump right in. So we can add and subtract matrices, as I said. They have to be the same, have the same dimensions. So they gotta be 2 by 2, both be 2 by 2, both be 2 by 3, whatever. Again, this adding example is 2 by 2. That does not literally mean every pair of matrices that we try to add together have to be 2 by 2. You could add a 3 by 3 plus a 3 by 3 or a 2 by 3 plus a 2 by 3. It doesn't just literally mean adding can only be done 2 by 2. Same with subtracting on the bottom. Okay. So when you're adding or subtracting, you are going to be given the matrices that you're adding and subtracting. And what we're actually doing is, I don't have my, I don't have my pen for my little board, so I'm improvise with my fingers, so it might be a little messy. We're trying to create these. We're trying to create matrices as our answers. So you're going to be given this, and you have to make a matrix as your solution, okay, or as your answer. So you're literally just adding the corresponding positions. A plus E. It's top left. This can be your top left number. B plus F is top right. It's going to be your top right number. C plus G, bottom left. D plus H, bottom right. Subtracting, again, everything corresponds down there as well. Okay. All right. So we've got, oh, that's, did not rewrite everything I thought I had erased. That is a 5. Everything else looks good. So let's start with that. Okay. Let's start with that. You're given two matrices. We're saying what they're equal to. Let's make our brackets. Again, I'm using my finger, so pardon me for not looking 100% clean. -3 plus 4. Again, while you're starting this, if you need to circle what goes together, if you need to write it out, again, writing with my finger, so pardon me if it doesn't look the best. And if you even need to punch that in your calculator, you can. -3 and 4 of those can give me 1. Top right, 4 and 0 gives me 4. Bottom left, 9 and -5 gives me 4. Bottom right, 6 and 7 gives me 13. Okay. So adding very, very quickly, knocked out of the way. Subtracting. So I left this up here so I didn't have to rewrite it because it would be a minute. So before we even try to combine the stuff with subtracting, you optionally have the option to distribute this negative. It's just like, when we are subtracting complex numbers, or if we were actually subtracting polynomials, like we talked about a couple weeks ago. Everything after this negative sign you would change. So -1 would change positive, 2 would change negative, so on, bringing everything down. And then you can make it adding. But, what you've actually done is you actually created more negative signs. And I think it just is unnecessary and can lead to just as much, if not more, confusion. So, you just got to be careful with what you're doing. I'll just use this first one as an example. I got 2 minus -1. So you get this minus -1. There's actually 2 negative signs. One doesn't replace the other. Okay. Again, if you need to actually write out 2 minus -1, you can. Punch in your calculator however you need to do it. But you're going to get 3. Top right, -3 minus 2 more, -5. Middle left, 5 minus 7 is -2. Middle right, 4 minus 8 is -4. Bottom left, -2 minus -5. Again, minus -5 is going to turn positive, so that would be 3. And then 8 minus 6, that's a 6, I promise. 8 minus 6 is 2. So there we go. So adding and subtracting, that easy. I could give y'all more examples, but it's that simple. Okay. All right, matrix equations. Trying to move relatively quickly so this video is not too long. There's actually 2 types of matrix equation. This first one pictured as a matrix equality. You got one matrix set equal to another one. Top left is literally going to equal top left. Top right equals top right, so on, so on, so on. And these ones are going to tend to, particularly the homework I gave y'all, have a bunch of variables that you got to solve for. Okay, so the examples I have, and I think most of the ones on your homework, you have to find A, B, C, and D. So you're actually trying to find those. You're not creating a matrix like we did with adding and subtracting. Okay. This is an actual matrix equation. So you have 2 equations set equal to a third one. And you basically make 4 mini equations down below. At top left, A plus top left E equals top left I. A plus E equals I. Top right, B plus F equals J. Bottom left, C plus G equals K. Bottom right, D plus H equals L. Okay? So four mini equations. Most are going to be two-step equations usually. Um, subtract or add a number to both sides and then divide by a number. But again, definitely stuff that y'all should be able to do. All right, so excuse me. This is our matrix equality. Okay. Um, and again, so we're just gonna go top left equals top left. A equals mine's touchscreen, isn't it? Oh, mine is touchscreen. I've been not smart, man, all year. So let me do this. I can actually write on my screen. All right, so you got A equals 4. There we go. B equals -7. Bottom right, 2C equals 8. Bottom right, D plus 4 equals 6. Behind my dual screens on my desk. All right, so A still just going to be 4. Yes. We're still solving for B, C, D. B is -7. That's already there. 2C equals 8. Divide by 2 on both sides. C is 4. D plus 4 equals 6. Again, that's plus, I promise. Subtract 4 on both sides. D equals 2. Okay? That's simple. All right, this one's going to be a little tough. This one's going to be a little tougher. Not too much tougher, but a little bit. So this is now a matrix equation. Two matrices added together to equal a third. So as I showed a couple slides ago, again, we're basically just going to create four mini equations. Okay, make these in purple. So you got top left, -2a plus top left 4 equals top left -28. Okay. Top right, 5 plus -6 equals B. Bottom left, -4 plus 11C equals 40. And then bottom right, I'm going to kind of put it over here because I need room for that one. 2 plus 1 equals D. All right. Let's do B and D real quick. D, 2 plus 1 is 3. B, 5 plus -6, which is the same as 5 minus 6 is -1. All right. Now, for A, -2a plus 4 equals -28. Subtract 4 from both sides. Gives me -2a equals -32. I would divide both sides by -2, which would give me 16. And then for C, add 4 to both sides. 11C equals 44. Divide by 4. So C would be, excuse me, divide by 11. Mess that up. My answer is 4, but I'm dividing by 11. Divide by 11, and C is 4. So there we go on that one. Okay. Yeah, you just gotta remember, everything top left, top right, bottom left, bottom right goes together, matches up. Make sure little mini equations. If even an example for this one, I don't know if there are any, but if I gave you a 3x3 matrix equation, there's potentially 9 little mini equations you have to make, but like I said, within the homework, you're really only solving for A, B, C, and D. So 5 of them should just answer themselves. Like instead of, I'll just say this, if you run into this on your homework, like instead of B, if that was -1, 5 plus -6 equals -1. That's just a true statement. Um, there's no variable in there to have to solve it. Okay. So it just makes a true statement. All right. Then what we talked about on Friday, we introduced scalar multiplication, which is literally just the distributive property. Okay. Literally just the distributive property, multiplying it by everything that follows. So the example, K on the outside, which is your scalar. Might remind y'all of your scale factor from the first unit of geometry last year, talking about dilations. So K times ABCD equals K times A, K times B, K times C, K times D. So the example is 2 by 2. We actually have a 3 by 2, or the general example is 2 by 2. The specific example is 3 by 2. Again, you're literally just going to multiply everything by 2. So 2 times 3 is 6, 2 times 2, -4, 2 times 1, 2, 2 times 5, 10, 2 times 2, 4, 2 times 2, 0, or 2 times 0, excuse me, 0. Okay. Here we go. That easy. Again, can't make that any more difficult. That is what it is. So what we could do with that is apply it to some of the stuff that we just looked at. Let me actually make the screen. Might help me when I'm writing. All right. Move my head down real quick. So if you ignore this 3 for a second, we see the addition problem I have up here. So it would just be like another addition one that we did previously where we got to make a matrix. But I forgot to script that. So since I do have that -3, what I actually have to do is multiply everything in here by -3, then add whatever corresponds over here. You could write them out each individually. You could even rewrite this whole matrix, multiplying everything in here by -3. I think it's simple enough where y'all kind of go one number at a time where you don't necessarily have to do that. So we're only multiplying this first one by -3. So if we're going top left, we're going to go -3 times 5, which is -15, plus -1 gives me -16. Okay. And top right, -3 times 0 is 0, plus 7 is 7. Bottom left, -3 times -2 is 6, plus 3 is 9. And then bottom right, -3 times 4 is -12. Add 2 back gives me, can't make a negative. Looks like an equal sign. -10. There we go. Okay. Below it, below it, again, it's a similar problem. Some of the stuff has changed, but a similar equation to what we just did. Again, really what you're gonna have to do in here is basically the same thing we just did. So 4 times -2 is -8a. And we're still gonna add the plus 4 top left equals top left -28. Top right, 4 times 5 is 20. It's a 0, not a 6. Plus -6 equals b. Bottom left, 4 times -4 is -16. Plus bottom left 4c equals 40. Then bottom right, 4 times 2 is 8. Plus 1 equals d. So again, you're solving for A, B, C, and D. Change my color. Bottom right, 8 plus 1 is 9. Top right, 20 plus -6 is 14. 20 minus 6 for B. Now A, again, -4 on both sides. -8A equals -32. Actually divide both of them by -8. I'm going to kind of do it sideways here since I didn't fully have room. And A is going to be 4. Now on the bottom, add 16 to both sides. 4C equals 56. Divide by 4. That is a C, I promise. And C is 14 as well. All right. Last one for the scalar multiplication. So you're going to see a similar problem to what we just did, but now if you look at this 4, it's outside of parentheses. And within those parentheses are both of my matrices that I'm adding together. Again, disclaimer if I need to say it, yeah, this example is adding all of them that have been adding, but you can also subtract as well. So since this 4 is outside those parentheses, really what you're doing is you're multiplying 4 to both of these. And again, you could do this kind of like we just did. 4 times -2A is -8A. Plus 4 times 3 is 12. Stick in top left equals top left -28. So this one isn't touched by the 4 because it's on the other side of the equal sign. So you can kind of do that one thing, one step at a time, but I think there is a little bit of risk there. Maybe forgetting to multiply, maybe when you get down to -4 and 7C, you do -4 times -4 is -16, and then you just put plus 7C equals 40. I think there is a little bit of risk to that when you're having to do this so many times. So with this one, where the 4 is outside of everything, what I would actually do is I would rewrite the problem. Again, your answer one isn't going to change. -28, B, 40, D. But I'll go ahead and multiply out everything else. So 4 times -2 is -8A. 4 times 5 is 20. 4 times -4 is -16. 4 times 2 is 8. Let's make a better looking 8. 4 times 3 is 12. 4 times -6 is -24. 4 times 7C is 28C. 4 times 1 is 4. My C's have been a little wonky. There. All right. So here we would still get -8A plus 12 equals -28 top left. 20 plus -24 equals B top right. -16 plus 28C equals 40 bottom left. 8 plus 4 equals D bottom right. Again, you're still solving for A, B, C, and D. D is obviously going to be 8 plus 4 is 12. B, 20 plus -24. 20 minus 24 is -4. Head. Subtract 12 on both sides. -8A equals -40. Divide by -8. Divide by -8. Would give me A equals 5. And then here, add 16 to both sides. 28C equals 56. Divide by 28. And C would be 2. All right. So that, got to show you the homework problems that you're doing. So that's your assignment. And if you have the homework, I will post which problems to do in Canvas as well. But the first worksheet, this front and back, you're doing every problem but 10 and 11. 10, 11 are like looking for the variables, not making a whole matrix, but you're only looking for a single variable, an X, instead of A, B, C, and D. So figure it was kind of unnecessary. And the second worksheet, the one that's a PDF of a page from the textbook, you're doing 1 through 6, 9 through 16, and 25 through 30. I'll need to be careful there. The section where 25 through 30 are is actually 23 through 30, but you do not have to do 23 and 24. All right, so that's your intro look at matrices. I think we're gonna have one more lesson after this on matrices. If y'all got any questions, you can always reach out to me in your mind. Ask them while you're working on your work during class. Getting ready to wrap up the school year. Got one more test to get a little mini test to go on this stuff, and we'll knock it out. So until next time, I will see y'all in class.